Hello friends, welcome to my channel. Let's have a look at problem 2331 together. Evaluate Boolean Binary Tree. For this problem, we shall give a recursion solution here. And actually, before we do this problem, we want to point out you are encouraged to try problem 2313. So that's a similar problem, but much harder. So first, let's look at the problem. We are given the root of a full binary tree, where the following properties hold. So leaf nodes have either the value 0 or 1, where 0 represents false and 1 represents true. Non-leaf nodes have either the value 2 or 3, where 2 represents a Boolean OR and 3 represents the Boolean AND. The evaluation of a node is as follows. If the node is a leaf node, the evaluation is the value of the node, either true or false. Otherwise, evaluate the node's two children and apply the Boolean operation of its value with the children's evaluation. So we are required to return the Boolean result of evaluating the root node. So below is a definition of a fully binary tree and a leaf node. A full binary tree is a binary tree where each node has either 0 or 2 children. A leaf node is a node that has 0 children. So here we can look at example 1, right? So in example 1, so the final result is true. The reason is, let's look at the subtree with root add. So because we have a false and true leaf, so the evaluation of the add is false. So we can have, so for currently the OR, the root, will have a left subtree evaluate as true and the right subtree evaluate as false. So together, true or false means yielding a true. So that's the return for example 1. For example 2, so it's a single node tree, and its value is 0, so we return false. So below are the constraints about the number of nodes, which is in the range 1 to 1000. In other words, we have at least 1 node. So the node value is 0, 1, 2, or 3, right? So this is a full binary tree as we specified. So for this problem, actually it's very straightforward. The method we are going to use here is a recursion method. So for this problem, we are going to directly write the code because the code speaks itself. And again, so it's good to have a practice for problem 2313. So for your convenience, if you find it helpful, you may refer to this video for an explanation for problem 2313. So with that said, now let's look at the code. First, in the constraint, the tree is not empty tree. So we're going to first check the special case is that the root is a single node tree, represents a single node tree. In other words, if not root left. So this one condition will be enough because the problem here is we concern a full binary tree. So if it has no left child, it has no right child. So in other words, this condition specifies the tree is a single node tree. So we are going to return root value itself. So this is the one case. So if the tree has both left child and right child, then we're going to use their evaluations incorporating with the root value. For example, it's either 2 or 3, right? So let's consider the case with value 2. So if root value equals 2, so this is a bitwise OR, right? So 2 is represents OR, Boolean OR. So for this one, we're going to make two self-evaluate tree. So we're going to call root left evaluation. Because this is OR, and here we're writing all, and self-evaluate call for the right subtree. So if one of the two evaluations for the child is true, then we're going to return true. Otherwise, we're going to return false. So this is for the case when the root value equals 2. So another case, and the only remaining case, is that when the root value equals 3. So we're going to have a logical add. So and here we change this code to be add. In other words, if both the two children evaluated to be true, then we return true. Otherwise, we return false. So that's a straightforward solution. Let's do a special case check for this problem. It passes the special case check. Now let's do an evaluation for the whole test cases. Yeah, it passes all the cases. I guess for this problem, that's it. Thank you very much.